I'm Professor Barbary, and I teach in the psychology department at Chaffey College. I'm going to show you an example of how to run an independent samples t-test in SPSS. Using the data set, I am interested in knowing whether the type of pet owned, and I'm interested in dog owners versus plant owners, makes a difference on happiness ratings on the scale that we used. So my independent variable is type of pet owned. This is a discrete variable, and there are two levels or groups, dog owners and plant owners. And the dependent variable is happiness rating on a scale. This is a continuous variable. Using our research question, I want to use my flow chart to determine which test we're going to use. So we start here at the top with question 1. Are my variables discrete or continuous? Well, one of them is discrete and one of them is continuous. So I would follow this path and then ask the second question, which variable is my independent variable? Well, that's the type of pet owned. And then I ask, how many groups does my independent variable have? There's 2 groups, dog owners and plant owners. So that brings me to question 4. Is my study independent measures or repeated measures? And because we only have dog owners and they don't also own plants, and then we have plant owners, this is going to be an independent measures test because each participant is only participating in one of the groups or conditions. So that tells me I'm going to use this independent measures or independent samples t-test. Looking at our data, I'm going to first start with variable view because I'm interested in pet type and happiness. So the pet type I need to look at because I need to see what the values are because this was a discrete variable and we had different values. So in this case, we actually collected data on 3 different groups, but I'm only interested in comparing 2 different groups. I'm interested in comparing dog owners with plant owners. So I need to remember the values. So dog is 1 and plant is 3 here. Happiness is here and it just shows you what the scale looks like if we look at the value label. So 1 through 7. This again is a continuous variable. So here's my data view. So this is the pet type. You can see that some people had 2s, 1s, and some people had 3s down here. So we're only interested in 1 dog versus 3 plant. And then we want to look at this happiness score. So now I'm ready to analyze my data. So I'm going to run my independent samples t-test by clicking here on analyze, going down to compare means, and I'm going to click on independent samples t-test. And now this is what I see, and in the test variable, that's our dependent variable, and the grouping variable is our independent variable. So for the test variable, remember it's the dependent variable, which is happiness. So let's look at which one is happiness. So it's right here. Select the number that best represents your level of happiness. I'm going to move this into the test variable box. And my grouping variable, the independent variable, what type of pet do you have? I'm going to move that here. And then you have to define groups. So you're comparing 2 groups only with the t-test. And so I'm comparing group 1, which is dog owner, versus group 3. I need to fix this because we had 3 different groups. And I'm not interested in cat owners. I'm only interested in comparing dog owners versus plant owners. So it's 1 versus 3. And I can click on continue. And sometimes when you click on options, it's going to give you means and standard deviations, but that's pretty standard. So I'm going to go ahead and click OK to run our t-test. So here is the t-test output. And what you see is the statistics. So we have the N's for each group, dog owners versus plant owners. We have the means and standard deviations when we look at the happiness ratings. So for dog owners, it looks like they have a larger mean on happiness versus plant owners. Plant owners have 1.95, whereas dog owners have 5.20. We need to see if that's statistically significant, though, that difference. It looks like dogs do have happiness scores that are higher, dog owners do. So the independent samples t-test, when we go down here to look at this, we're going to first look at the Levene's test for variances, because we want to make sure that we have the added calculation if the variances are in fact different. So if this F for the Levene's test is significant, then we're going to have to do extra calculations and read the second row. But this is not significant because it's above 0.05 at 0.268. That is above 0.05. So that means it's not significant. And that's telling us that the variances between those two groups are not significantly different from each other. So we don't need the extra calculation. Then we look at the t-test here on the top row, and we can ignore the second row, the bottom row. So we're looking at the t, the degrees of freedom, and the significance. So this SPSS program looked at the one-tailed versus two-tailed. So it already did the calculation for us. Now, my hypothesis, I did not state, but if I stated a hypothesis that was very vague, that said there will be a difference between pet owners in terms of dog owners versus plant owners, then that would be a two-sided test. So you need to know if your hypothesis is a one-tailed, where you make a specific prediction about which group will have higher scores for happiness in this case, or whether there's just going to be a difference, and that's two-sided. So in either case here, you have the same p-value, but that's not always the case. Let's imagine that it was a two-tailed test, and this is less than 0.001. So that's great. That's very significant. And we're looking at the significance level being below 0.05, remember.